Hello and welcome to this section of the MATLAB tutor. Here we're going to do something very useful, and that is talk about row-reduced echelon form of a matrix. If you study matrix algebra, you learn that you can use matrices to solve systems of equations really easily, and that's one reason they're useful. So let's define a matrix A that's going to hold and represent our system of equations. And let me show you what I mean by that. Let's just do something simple. 1, 2, 3, semicolon, 4, 5, 6. Now, obviously this is a matrix. We've been talking about matrices for a long time. But how does this represent a system of equations? If this represented a system of equations, it would be two equations. The first equation would be represented by the first line, and the second equation would be represented by the second line. So if I translate this to a system of equations, this would be 1x plus 2y is equal to 3. That's the first equation. And the next equation is 4x plus 5y is equal to 6. So you see, you can kind of imagine a little equal sign here or a dotted line here. The numbers on the right-hand side in the right-hand column represent what's on the other side of the equal sign. These guys represent the x values of the equations, and these guys represent the y value. So I have two equations and two unknowns, and I know that I can use algebra to solve this. I can do graphing, I can do substitution, I can just plug it in the calculator. I can also use matrices. So there's lots of ways to use matrices even to solve this guy, but one way is to take this matrix, which we call an augmented matrix. The reason it's called augmented is because it's got the equations with the sort of like representing the variables, and it's also got what's on the other side of the equal sign here. We can do manipulations to convert it to what we call row-reduced echelon form. And let me just show you what it is. This is not something I'm going to teach you how to do by hand, obviously, in a tutorial like this. I'm going to teach you how to use MATLAB to calculate it. But for those of you taking linear algebra, you've done this before, all by hand. So row-reduced echelon form is RREF, row-reduced echelon form. That's how you do it. And literally all you do is you pass your augmented matrix to it, your matrix, right? And then MATLAB comes back with the answer. Now you need to know how to interpret this answer. Basically, when you have a matrix like this, there are rules of algebra, rules of matrix algebra that you can apply to transform this matrix to this one down below. There's ways in which you can multiply and add and subtract this top matrix to basically manipulate it so that it looks like this one. These two matrices basically represent the same thing. It's just that this one is the original set of equations and this one is our simplified version. Think of it as simplifying a fraction. You get something that looks different, but it really represents the same thing. So if we apply the same interpretation, what this is saying is that 1x plus 0y is equal to negative 1. This one's saying 0x plus 1y is equal to 2. So by reading the matrix, you can immediately see that x is equal to negative 1 and y is equal to 2. And so effectively, you've solved the system of equations. So the answers here, if I were to write down what x and y was equal to, x is equal to negative 1, y is equal to 2. And if you plug the values of x and y in here, you'll see that it does satisfy. I mean, you can do that. X is equal to negative 1, y is equal to 2. So negative 1 times 1 is negative 1. 2 times 2 is 4. You add those guys together and you get 3. And if you do the same thing for the second equation, you'll get the answers. So this is the solution. MATLAB has done the row reduction for you and presented the final augmented reduced matrix for you. And once you have it in this form, you just read off the answers. X is equal to negative 1, y is equal to 2. Now let me clear the screen, and I'll put another system of equations in here. 3, negative 5, 3, 7, next row. 5, 5, negative 7, negative 8, next row. 0, 1, 2, 3. So here is another matrix. And in this case, it's actually three equations. The first equation is this one, the second equation is this one, the third equation is this one. So you can envision your dotted line here. Everything over here is on the right-hand side of the equal sign. So the way you would interpret this is 3x minus 5y plus 3z is equal to 7. 5x plus 5y minus 7z is equal to negative 8. 0x plus 1y plus 2z is equal to 3. So you have three equations and three unknowns. And again, there's many ways to solve this. You could do substitution, all that stuff. But once we represent it as a matrix, one easy way to solve it is just to apply the row-reduced echelon form to it. If you do it by hand, you have to use the rules that you learn in your classes to manipulate all this stuff. But in MATLAB, you just pass it the matrix, and out comes the row-reduced form. Notice that along the diagonal, you have 1. just like we had the last time. You have zeros everywhere else, and that is the end game. That's what you shoot for when you try to simplify this. So these two matrices, even though they look different, they really represent the same system of equations. Just like two different fractions can look different, but they're the same thing. So this one is 1x plus 0y plus 0z is equal to this number. And this is 0x plus 1y plus 0z is equal to this number, and so on. So what you really can do is read off the answers directly. X is equal to 0.6466, y is equal to negative 0.0862, z is equal to 1.5431. So that's it. That's the row reduced form. And that's why it's useful. You take these augmented matrices, you use the row reduction techniques to get to this, what we call row reduced form, row reduced echelon form. And once you have it in this form, you can just read the solutions directly off. So if you take these values of x, y, and z, and you stick them into your original set of equations, they'll satisfy it. That is the solution. So RREF is your friend if you're trying to solve a quick system of equations. The easiest way to do it in MATLAB, honestly, is just to stick it in a matrix, row reduced echelon form, boom, you can read your answers directly off the matrix.